Hello, this is Todd Danielson, the Editorial Director of Informed Infrastructure. Welcome to this podcast on mobility digital twins. Joining me today are Michael Clark and Daniel Florian. Gentlemen, why don't you introduce yourselves and tell us what you do and how both of your companies were acquired by Bentley Systems as part of its digital twin strategy toward mobility.
Thanks, Todd. This is Michael Clark. My company called City Labs was acquired about a year and a half ago. My background is as a hands-on person that was doing traffic forecasting, building traffic models for about 40 years. My role at Bentley, since we've been acquired, is as a senior director of mobility. What I do on a daily basis is, I guess my role is kind of leading strategy for the group.
Sure. And this is Dan, and the firm that we come from was actually competing with Michael's firm, but we are also we're building software to implement models of mobility that users can use as a virtual laboratory to test the impacts and interactions of population and geography and demographics on transport infrastructure and help us measure mobility and transport system performance. And we also have a long tail in terms of experience in this field. And we've been quite interested in following the scientific methodology over the years. And we were quite impressed with Bentley's vision for the importance of understanding mobility and their commitment to looking at how we can really, from a multimodal perspective, look at moving things forward in terms of the simulation and analytics that we use in this space.
Okay, so you've both been developing software for understanding mobility for a long time. And this kind of software obviously impacts infrastructure in many ways. So can you tell us how your software end users are able to explore mobility and create better mobility models?
So I guess I go way back, and this field started by building software that allowed people to build a model of an urban area. And the focus at that time was really on being able to test and forecast how many cars would use a widened road or a new road and what kind of congestion alleviation, if that's a word, would occur. And then over time, those models have gotten more and more complex as the questions that people seek to answer have gotten more and more complex, from moving on from forecasting simply roadway traffic volumes to forecasting rail volumes and transit usage to even much finer levels today.
There's a really interesting interplay between the models that we build and the influence on infrastructure. It's really profound. I mean, if we go back, and I know Michael has the history on the industry here as well, we really think that we can follow the progression of our cities, with the interplay here. For a long time, there was this, at least in the Western world, this very high propensity for car ownership and traveling by car. So for a long time, this was really about project ranking different kind of infrastructure, road infrastructure scenarios. And so, yeah, we test, hundreds, thousands of scenarios that, of course, you want to do before you actually break concrete and do things in the real world. But where things got interesting is when we started to reach the bounds of what that infrastructure can handle. And we realized that it's not pleasant to sit in congestion. Somewhere in the 90s, right? And it's certainly exacerbated in certain parts of the world. So, there becomes a discussion about, well, if we're forecasting increasing car congestion from these models, where do people go? And so the first thing was, transit. Let's get our transit systems online. Let's invest in the transit infrastructure. And, then you look at, well, okay, how do we get more people riding transit? And the shift becomes transit-oriented developments. Let's put people and design cities so that they're near the transit. But at a certain point, a lot of people still want to travel by car. So we ran into things and solutions like congestion pricing. And every time the industry moves forward and we think about our cities in these ways and our mobility in these ways, the models get exercised to run, thousands of scenarios to understand what that's going to look like before we actually get there. I think it gets more and more dramatic. I could tell you about one particular city where we were actually handling questions about, how can these forecasts make sense? The models are telling us that congestion is going to rise beyond what's tolerable, and there's just no more capacity on the transit systems for people to really get into the CBD. And we saw the modelers struggling with this, but the interplay that they have between their group and the urban planners and the city planners is fascinating, because they really present a problem. And we saw this in a couple cases where it's really at the bounds of the available, road capacity. There's no more bridges or tunnels that can be built. And transit can't solve the whole problem on its own. So, the vision for the city was really, let's get the density in the CBD as high as Hong Kong. And you can imagine that kind of infrastructure. And the city had to pivot. And this whole strategy changed to, new thinking, like a multi-nucleated city. Now suburbs are well underway. There's infrastructure to support satellite cities and local commutes. And all of these are ways to match, all of the targets, like, what is an average commute time? What is our congestion level going to be in? And how is it fair to travel? And so, the interplay between the models that we've been building and the infrastructure that we've seen in the cities is really profound. And of course, it continues today.
Michael, is there anything you want to add on to this topic before we move on to the next discussion?
I think Dan brings up a lot of interesting examples, and I'm especially kind of taken by what he said around road pricing. And certainly a lot of cities around the world have, done quite a bit on this. London is a primary example, but even as, kind of exemplified by toll roads, and urban toll roads have really grown over the past 20 years in a lot of cities. I worked many years ago in Orlando, back in the day when I should have bought a lot of property in Orlando, but and the forecast that we were putting out for Orlando showed tremendous growth. And it was almost to the level that when these results were presented, people found them unbelievable. That how would Orlando grow so strongly if we're going to have all this kind of congestion? And it kind of stopped the thought a little bit. And I think in hindsight, I kind of look at that and I see what happened, that we kind of ended up with building a lot of urban toll roads in the Orlando region to kind of control flow and to monetize it. And it's been an interesting case study, I think, and how U.S. cities that are relatively spread out, like Orlando, have kind of coped with the strong demand for building infrastructure, but how to pay for infrastructure, and also how to kind of control the flow and mitigate the impacts.
All right, great. So mobility has been changing rapidly, and especially now with the recent pandemic. So which shifts have you seen, and how are you supporting users to make these adjustments?
I think there's a lot of things to talk about here, Todd. The one that's the most obvious is obviously nobody saw the pandemic coming. And when you look at what the questions are being asked about travel and mobility during the pandemic, it's really about telecommuting. Nobody saw that, most people would start, at least where they could, work from home. And this massive shift to e-shopping instead of visiting retail, and in certain areas where the stores are closed or there's lockdowns. And the real reason that this is interesting to modelers and to what we do with the software is that these questions kind of surpass the longstanding assumptions that we've had in the kinds of models that we build. Historically, we've looked at generally the behavior of say, an average individual in a part of the city characterized on certain dimensions. So, it might be this is a household with, 1.8 children, right? And we're looking at the averages. But unfortunately, when you look at things like telecommuting or even things like new mobility and ride sharing, unfortunately, the average behavior is not the average of the individuals, right? And so you have to get to the real individual drivers of all of that. Here's an example. If you've got two kids who need to get to school on time and you're the primary caregiver and it's during the pandemic, but you're getting out and you're already in the car, the propensity that you add a shopping trip to what's called your tour is probably quite high. Throw on your mask, you go in the store, conduct your activity there traditionally. But if you're single or you don't have those dependents or someone else is taking care of the children for you, and you're able to work remote, probably that becomes, ordering online. And so think about the difference in terms of the mobility system and what that infrastructure has to support. One is a freight delivery, right? One is an extra car trip, perhaps. And the same can be extended. In order to model all of this, we really want to get to this full individual micro simulation, a full understanding of the individual in these kind of completely synthetic, but virtual and statistically significant representations of urban mobility. That's really a big drive for the tools that we want to make easier to use and get to the users. But the interesting thing is, and there's something profound, and then I'll let Michael chime in, but the thing that happens is that with these kinds of models at this level, you get this enormous fusion of data. It's not just about transport anymore. It's about the economics of the city, the industries, are people working at retail or, in going to universities. You end up bringing in so much of this data, and it becomes such a visual representation that all of these numbers, become much easier to interpret for a broader group of people. And the questions they can ask of these models become much more profound beyond just transport. I was in a recent, couple of years ago, we had a fortunate situation to present some visualizations from one of these models. There was one agency in the Phoenix region, which is one example of a very forward-looking agency who was ready to invest in some of these tools. And as we presented these kinds of models to an executive board, the kind of self-realization and the ideation, if I can use that word, and the conclusions they were reaching without necessarily going through the transport team were profound. I mean, there were exclamations about, and the reason there's traffic is because there's not enough jobs of this kind in this part of town. And so, what happened was we had a transport model, and it really became about a much larger discussion about mobility in case of the city. And I think that this is really an interesting direction. And I think something that we're definitely moving towards.
Dan, I think you bring up a lot of good points on that as well. And that this kind of recovery or coming back from COVID is kind of an individual choice, a lot of our household choices, and the ability to kind of represent how that happens within a transport model or a model of mobility is pretty important. I would also say another thing that kind of comes to mind is I remember when COVID when it kind of started, and you'd go outside and suddenly there was no traffic. And as someone that built and sold traffic forecasting software, I was somewhat alarmed. Hey, where'd the golden chalice go? We'd always have traffic. We'd always have a business here. Now there's no more traffic. But it's kind of, we kind of all, I think that how things were will come back at some point. But it is a question of how fast and when, and will that be kind of in certain cities, but not in other cities? Will cities kind of spread out? I mean, we can see certain cities that have lost population and certain ones that have grown over the time. And I think one thing that our team has been looking at a little bit is how to kind of leverage what's available now in kind of big data in mobility of all the connected vehicles and the mobile devices. And we kind of are trying to pull out a good understanding of what is going on. And this is something that transportation modelers, forecasters, planners kind of have struggled with, that up until the availability of that type of data, it's been a real challenge and very expensive to gather information about what is going on out there. We'd have our traffic counters, and then we'd do these very expensive and very hard to do traffic or household travel surveys that try to capture what's going on and how different household types are doing things. But with this advent of kind of big data in mobility and connected vehicles and infrastructure and connected devices, everybody being connected and every vehicle being connected, it kind of allows us and kind of changes things a little bit to have a really good and rich understanding of what's going on. And my view is that as the world comes back, it's important to understand what is the current situation and then kind of forecast off of that situation, because I think it would be a little hard to kind of go in and kind of, okay, I mean, at some point, transportation planners put up charts showing this is where we are today, and this is the forecast in 10 years or 20 years. And it's going to be a little bit hard to know what do you put up on that chart for what is today, because it's quite different from what it was a year ago.
Yeah, I think it's interesting that one of the challenges for mobility infrastructure modeling is that there's so much more of a human element than a lot of the other infrastructure that's a bit more about the assets. What are some of the major challenges you have modeling humans and keeping all of your things up to date the way it changes so rapidly by the minute?
Let me jump in on that one, Daniel, because I find that, you know, this whole concept of a digital twin of mobility is quite different from what is typically thought of as a digital twin, which is usually kind of a digital twin of the physical infrastructure of a factory or something along those lines. And what we're trying to understand here is what is the current state of the movement of humans and of vehicles through cities. And it's quite a challenge. And we can do that, but we're really helped more and more by sensors and probes, right? Everybody has a phone in their pocket, and that is sensing, detecting movement. And I know we're all worried about privacy, but you know, that information can be used at a certain spatial scale where you protect privacy, and it still gives very valuable insights to transportation planners.
Yeah, that's right. And I mean, I agree with that. And I think we have a lot of potential, and some of the things we're working on are exploiting that as we go forward. You know, the having the data, I think, and I think Michael pointed this out, right? Having the data is where a lot of current initiatives and efforts end, right? We know what's happening now, but where we think there's a lot of value is, you know, how we can use that to answer questions downstream. And you're absolutely right, Todd. I mean, people make up their own minds. The infrastructure is kind of what humans decide, and it goes where it goes. But modeling people is far more mercurial. So when we look at these models, we're less using them to forecast a number, right? And we're really looking at testing response over a range of possible scenarios, right? I mean, that's really where these things get interesting. And you know, when we look at the data that's available, there's a lot of excitement now. You know, the kinds of models that we do are fascinating and they're so profound, but they're hard. There's still an effort in doing it. You know, there's a lot of variation in the data that's available between regions to do this work. And there's a lot of customization going on because, you know, these things, you have a lot of local differences. But as the data becomes more frequently updated and certainly standardized, I think we have a big opportunity to offer the kinds of models with the realism and the individual detail that we're moving towards, together with these kind of frequently updated, you know, quick moving data sets, so we can get models that are automatically updating in time. And I think that there's a lot of opportunity beyond, say, you know, we've got great users now and great teams and a lot of planning agencies around the world who are great at what they do, and they really handle the hard questions. You know, what is going to happen in the future, and what ranges of sensitivities do we want? What is fuel price going to be? How are people going to respond to the pandemic? All these questions are hard questions. Long-term forecasting, I think, is always going to need that kind of expert, you know, scenario testing and building. But I think that there's a lot of opportunity in that fast-moving data to connect it more directly, maybe for different kinds of applications, or to democratize access to these kinds of tools across a broader user base. And that's definitely, you know, a very interesting thing. I mean, just this morning, I was talking to someone from a city who was telling me that, you know, I will leave the city nameless, but their city plan was pushing for a target of 50% transit mode share. Now, of course, this is pre-pandemic, so let's leave aside the pandemic for a minute. But you know, the models are telling him that no matter which way he bends this, there's no way to achieve that goal. So I think that, you know, the role of all of this, especially together with this new data source and the additional detail here, is really opening up some really exciting possibilities and good goals for us moving forward.
So each of your mobility products have been doing a lot of great work for a long time. But now that they're part of Bentley's digital twins platform for platform for mobility, how will this open up new possibilities?
I'll jump in on that one, Dan. I was the one that said, hey, we ought to go acquire those guys. And I think for good reasons. I think that there's a lot of good integration possibilities between what our two firms have been doing. We've both had kind of our core competing systems for many, many years. But each of us has also chosen to invest in new developments that are not really directly competitors, but could be quite complementary to each other. One of those is our team has been working quite a bit on this big data concept and trying to pull in massive amounts of information, location-based information, and create a full, complete, fully scaled understanding of how many cars are going down streets, how many pedestrians, where are people going from and to throughout the day, hour by hour, maybe even 15 minute by 15 minute, day by day. And because we found that as one, a market opportunity, but we also thought it was something that transportation planners kind of starve for data on what is actually the situation. We kind of get little bits and bytes of information by looking at a Google map and seeing a red road and knowing there's lots of congestion there. But we don't necessarily understand those people going down that red road, where are they coming from and where are they going to? And how do they vary by time of day? And therefore, can we plan infrastructure or design some kind of a response that would mitigate that situation in kind of a smarter way than maybe we've done in the past? On Dan's side, well, I'll let Dan talk about what he's doing. We've been particularly impressed by what they've been doing and what he'll call kind of activity-based modeling or agent-based modeling, but also what they do in traffic simulation work.
Mm-hmm. Yeah, I mean, ultimately that's what it is. You know, our team has been focused on a lot of initiatives for quite a long time, and it's quite moving quite quickly now. But this individual realism, both on the supply side, you know, the networks, the trains, the crowding, the traffic, but also on the demand side, you know, and we've already discussed on this call, we'll get into it again, about the importance of the individual and understanding that from a real synthetic population that, you know, reflects a lot of our statistical data sources. But it's really, you know, when we look at these things together, that's really the possibility to bring these things forward. You know, the models have always been kept distinct from the data. And as we have opportunities to use them together, I think there becomes an opportunity to look at things in a different way. And I think that that we get to answer these questions. You know, one topic that I think about a lot when I hear the term digital twin is, you know, a lot of this short-term kind of questions. You know, well, there's an accident on a road and what's going to happen in 15 minutes? You know, the truth is that, you know, I'm going to make some bold characterizations now, but you know, if you know how many, to Michael's point, if you know how many cars are traveling down a particular roadway, you know, the technology to tell us what does traffic congestion and queuing look like on that section, you know, that's accessible now. What's a much harder problem is as we zoom out to the metropolitan or to the regional scale, you know, nobody has a perfect understanding of who's traveling where. It's impossible to observe that data at scale, except maybe at approximately at certain very large tech firms who, of course, have no ability because of privacy and confidentiality concerns to leverage it. So the truth is the entire industry is working with only ever a guess about where people are moving. And, you know, the idea that we can address that question and answer that fundamental question of who's moving and where and when, that opens up the possibility for all of these other applications. And really, there's a lot of convergence there. So that these are, you know, very interesting directions. And I think the broader resources at Bentley are going to be quite interesting as we explore this together.
Well, thank you, Michael. Thank you, Dan. I really appreciate you taking the time to help our audience better understand how digital twins are improving mobility. And I look forward to future discussions on this topic.